GDP's rising. GDP's rising. Bye, bye, bye. Dollars in the sky. Da la 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 la. Hey!
Hi everybody, this is Dr. Watts, and I'm going to walk you through the Homework 2 problems for Principles Macro, Econ 221. First tab we have here is calculating nominal GDP for our simple economy, only 3 products, 2 years. And you'll notice here, remember that GDP is sum of price times quantity. So I have the quantities and prices for each product for each year. So in 2017, this economy produced 600 pizzas at $10 each for a total of 600 worth of pizza, right? That's going to be the 600 pizzas times the $10. I'm just going to use cell reference to calculate the value of each, the total value of each item that I'm going to fill. So I see that we produce 4,000 worth of beer, 800 6-packs times $5 each, and then $1,200 worth of Chuck Norris videos, 100 videos at $12 each. Okay, so price times quantity, price times quantity, price times quantity, and then GDP is the sum of those 3 price times quantity products. So total GDP was 11,200 in 2017. For 2018, it's going to be the price times the quantity for 2018. So I'm just using the cell references there, just using a basic formula. 68.20 worth of pizza, 46.75 worth of beer, 11.88 worth of Chuck Norris DVDs, and then you can equal sum here, those 3 values. I like to do the auto sum here. If you have contiguous range of cells you want to add up, you just hit Alt equals. On a PC, on a Mac, I believe it's function shift equals, something like that. Okay, so we had 12,683 worth of total production in 2018. And now I want to calculate the growth rate. Remember, that's x2, the second value, minus x1, the first value, in parentheses, divided by the first value, x1. So what that's going to look like in Excel is this, the second value minus the first value divided by the first value. So it's basically the difference in the two, in this case an increase of what, about $1,400, divided by the starting point, which is $11,200. And that's already formatted for percent. So we've got about 13% nominal GDP growth rate. Now, that sounds great, but we want to scrutinize that. You know, was that because we have more products? Well, we have more pizza, we have more beer. That goes from 800 to 850. We have a little bit fewer videos. It looks like overall we do have more products, but is it really 13% more? Well, part of the increase is in the prices, isn't it? And actually here I just had all prices go up by 10%. So the price of pizza, beer, and Chuck Norris videos all went up by 10%. So I'm thinking the real change in the value of production is not 13%. In fact, I can probably estimate it's about 10 percentage points less than that, because 10% increase in the prices. So let's jump over here to real GDP. We're going to do the same type of math, but we're going to hold the prices constant where? 2018. Okay, so it's real GDP 2018. Actually, let me type that in here too. Real GDP $2018. That means we're using 2018's prices for every calculation. Okay, so for 2017, I'm using 2017's quantity and 2018's price, 600 times 11. So in 2018 terms, we had 6,600 worth of pizza produced in 2017. And then likewise, I can just fill this down for beer, 800 beers produced in 2017 at a 2018 value of $550 each. That's 4,400 worth. And then 100 Chuck Norris movies in 2017 at a 2018 value of $1,320. Alt equals, auto sum those. Okay, so 12,320. Let's match that color to the rest of them. And then of course 2018's market value in 2018 dollars is already there, so we just do the same thing we already did. 2018's quantities times 2018's prices. Okay, now I see I have a much less, I only have about a $300 increase in real GDP here, and my percent change is second value minus the first value, parenthesis, divided by the first value divided by the starting point. It's only 2.9. Yeah, I said it's approximately going to be 10%, 10 percentage points less, and indeed, that's almost exactly true. Okay, so that's still a decent real GDP growth rate. 3%'s nothing to sneeze at, but the nominal GDP growth that we observe there is going to be extremely misleading unless we correct it for the change in prices, inflation. Right, so real GDP. Now, here's a little bit more complicated. Let's move to the next tab, the real GDP the easy way. A bit more complicated economy, of course, still not nearly as complex as the real economy, but this one has now 10 products, and we're looking at a 6-year time period. Oh boy, this looks like it's going to be tedious. Well, not really, because Excel has a function, you'll recall, that will add up the sum of a bunch of products. So this number times this number plus this number times this number plus this number times this number. Well, that's what GDP is, right? It's that sum right here, the sum of price times quantity. So if we just use the sum product function, which I'm going to use down here, notice that the arguments it asks for are array 1, array 2, array 3. So we could add up the sums of products of two or 3 or 4, however many numbers we want. In this case, we only need to add up the sums of products of 2 numbers. So it's going to be every number here in column B for the 2014 quantities, rows 3 through 12, comma, and then every number in column C, the 2014 prices, 3 through 12. And if I just hit enter, what it's going to do is take that times that, plus that times that, plus that times that, that times that. Okay, so I got 708,000 roughly worth of goods produced in 2014. Now, beauty of Excel, as always, is cut and paste, or copy and paste. So I'm going to copy this formula, Control C, then paste it here. And because we didn't use absolute references, we used relative references, guess what's going to happen to those cell references when I copy over here, when I paste rather over here? They're going to slide over each one 2 columns, right? So looky there. So Control C, Control V, Control V, Control V, Control V, and let's just go into that one and check. Yep, every time it's sliding my cell references over. So now for my 2019 result, I'm doing the sum product of L 3 through 12, 2019's quantities, times M 3 through 12, 2019's prices. So there we go. There's our nominal GDP series for this data set. Now I want real GDP in 2019 terms, in the prices of the last year, the latest year. So how do I do that? Well, again, we can run a sum product. And for 2014, I'm going to take 2014's quantities, of course, so B3 through 12 again. But now I'm going to use 2019's prices, right? M3 through 12. And now I'm sure the more astute among you have recognized already that we only need to enter this function once as well. If I lock in the 2019 prices, whenever I copy and paste this, it'll keep those put. They'll stay put there in M3 through 12. If I lock them in, how do I do that? Dollar signs. Okay. So I just press F4. That's a shortcut, but you can put $M, $3, comma, $M, $12. And now they're locked in there. And watch what happens when I copy and paste that function. Okay, now I'm using D3 through 12, which is 2015's quantities, times, again, 2019's prices over here, right? Copy, paste, 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 paste. And let's make sure we're getting the right thing over here. Yep, 2019. And 2019's nominal GDP and real GDP should be the same, right? Because 2019's real GDP is in 2019 dollars, which would be the same as its nominal GDP. So remember, the base year, nominal and real will always be equal. Okay, now let's calculate our growth rate of real GDP. Of course, we can't do that for 2014. I don't have the previous year to compare to, but for 2015, I can take 2015's value minus the previous year's value divided by the starting point, which is the previous year's value. So D14 minus B14 divided by B14. It's already formatted in percent for you. And then again, just copy, paste, 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 paste. And we see here that GDP is going up and down. Here we had a recession, GDP went down, it comes back up. Okay, so just some made up data just for practice, but you get the sense of what GDP is doing, right? It's sum of the price times quantity, so it's capturing the market value of the production of all goods and services in that economy. GDP, very important concept. Okay, now let's move on to the other thing we covered in Unit 2, which is the solo model, the growth model. I just uploaded a brand new lecture video on this, so if you weren't in class or you weren't keeping up, you can go back and review that lecture video on the solo model. So I'm assuming you know how the model works and kind of understand its outline. So we're just going to jump right in here and build the model and find the steady state results. So we want to create values of capital from 0 to 1,000. So all I need to do is start typing in the capital column 0, 1, 2, 3, and then select that range of values and then go down to the fill box down here, the crosshairs, and fill it, and you'll notice Excel will figure out the pattern. It's increasing by 1 every time. So I can just take and fill this now all the way down. I think I want 1,000, so I think I need to go to 1,006 because I started in row 5. So fill this all the way down to row 1006. Oh, 1005. Okay. Yeah, 1005 to 1005 includes this. So we got possible values of capital from 0 to 1,000. Now what? Well, now I want to put in the model here for output. Output is A, the technology factor, times the square root of K. And K is going to be given by this value here. So for every possible value of capital, what would our value of output be? Here my technology parameter to start with is 2.0. It's given in cell B2. Remember, I need to lock this because I always want to multiply the square root of K by that technology level. So I want that to be an absolute reference times the square root of capital. That's going to be a relative reference, so it can slide as we fill. Okay, now there's our output function. You'll see it pop up on the graph. It's pretty steep because I've got a high technology level to start with. That's fine. Okay, then what is depreciation? Depreciation is the depreciation rate, and it's always going to be that rate times the level of capital. So for this value here, K is 0. That's an A5. Of course, that's going to be no depreciation. There's no capital yet. But as we fill that down, you'll see that as we build up capital, we get a steady increase in depreciation. Right? It's a straight line function. You can see that in the graph as well over here. You can see the red line populate, or the orange, whatever it is. That's depreciation. And then finally, the investment function. What is that? That's the investment rate. Once again, lock in the cell reference of where I have the investment rate parameter up here in D2 times the level of output. Investment is a function of output, so times the output level in B5. Of course, that's going to be 0 when there's no capital, there's no output, right? But then as we grow capital, we see that we grow investment. But investment also grows at a diminishing rate because it's related to the output function, so it has that kind of bent down shape as well. And then my solver with my solver algorithms that I've put in there behind the scenes. Notice that this is an index match function. I'm looking for the values that match for D and I approximately. So I got a capital stock of 64 and an output then of 16 for my steady state. Okay, so that's how you would approach building the model. Now in the homework, you might have some different values up here, but the way you'll build the model will be exactly the same. You will create your range of possible capital values, and then you'll run your output function with this technology parameter and this capital value. Then you'll run your depreciation function with this depreciation rate. You'll run your investment function with this, whatever is given in the homework file. So same exact procedure, probably have some different values as inputs into the model. Okay, then the final thing I'll ask you to do in the homework, you jump over to Solo Model with Solver, is to we've copied over the same parameters we started with for technology and depreciation rate and investment rate. And then I've just got some scenarios I want you to work through and then fill in the results in these color matching boxes down here. So scenario 1, it says increase the investment rate by 50%. So you could actually just, it's 20%, right? So I could actually just do equals 1.5 times 0.20. It's it's 30%, right? I could have done that in my head. I know that 50% larger than 20 is 30, right? Because 50% of 20 is 10. Add that back to 20, that's 30. So increase my investment factor. Actually, before I do that, I want to write down what I call the baseline. I think in the homework I made this. I made a box right here to write down the initial starting point. So our initial starting point was output of 16 and capital of 64. I'm just going to keep that there just so we can kind of remember, have our comparison values. Okay, now let's increase investment by 50%. And this is my new steady state at this investment rate. So my capital stock is going to be this, 144. My output is going to be 24. And then I want to calculate the percent change over the baseline. So that's the change from here to here now. So it's the difference between 24 and 16 divided by 16. It's 50%. I calculated that. Now I'm just going to write it down because these values will change when I run my next scenario. And let's, I think in the homework I have that formatted percent-wise for you. So 50% increase in an output when I had a 50% increase in investment. Now keep that in mind. And we want to compare what happens when we have a change in technology. Okay, so scenario 2 says reset the investment rate to its initial value. Oh, it was 20% here, wasn't it? 20%. Reset that to 20%. Now increase the technology factor by 50%. So what's 50% higher than 2? What's 50% of 2? 1, right? Half of 2 is 1. And then increase it by that amount. So it's going to go from 2 to 3. So I can just plug that in. It's easy math. Okay, and now record those steady state results down here in these blue cells. So I have output now at 36. Capital is at 144. And my percent change over my baseline is now this. Is going from 16 to 36. So it's the difference between 16 and 36. Divided by my starting point, which was 16 again. So 1.25. I want to enter that just as a number now and then show it as a percent. 125%. Okay, so my basic conclusion then, and in the homework I'll ask you, say which factor has a greater impact on the steady state of output, investment or technology? Well, I had a 50% increase in investment. I got a 50% increase in output. With a similar 50% increase in technology, I get a whopping 125% increase in output, right? So technology is the bigger factor. That's the main lesson here from the model. Well, that's one of the main lessons, a few other lessons. Okay, and then finally scenario 3 says reset your initial values. In this example here, I had 20% and 2. Reset technology back to 2, investment back to 20%. Now find a combination of a higher technology factor and a lower investment rate that generates the same steady state result from for output from scenario 1. So I want to get output back to 24 again. I want to do that this time with a lower level of investment. So I want to show you that with a big enough increase in technology, I can actually reduce investment and therefore enjoy more consumption and still get to this higher level of output. So let's just plug in some numbers here and see what gets us there. So if I reduce investment to 10 and technology to 3, I still don't get there. I'm trying to get to 24, remember. I'm trying to get to this scenario 1 result. So let's put investment at 15. Okay, and then output would go to 27, so I can have technology even a little bit less than that, 2.5 maybe. So 2.75. Okay, so you can kind of plug in some numbers here and you can find something else. So it's going to be something close to this. And there's a whole bunch of combinations you could do for this because you could do it for any lower investment rate. Okay, so I just want you to find a combination that works or gets pretty close. Let's try 2.85. Okay, I would call that close enough. So I'm basically matching the output from scenario 1, 24. But remember, that was at a 30% investment rate. That was at a higher investment rate. Here I've got a much lower investment rate, and I've gotten there by increasing technology. So I'll just record the numbers I got here. I have capital of 73 and output of 24.4. Close enough. and my percent change over my baseline is going to be now 24.4 minus 16 divided by 16. So it's approximately 52%. Okay, so demonstrating that the power of new technology in the economy, we can have less investment and still have growth and output with an increase in technology. Okay, so there you have it. That's the solo model. That's how I want us to learn how it works, how to plug it into Excel. Hopefully this will help you burnish your Excel skills as well. And we understand economic growth, I think, pretty well now. So that's it for Unit 2.